Hello everyone, good evening. Okay, so
Good
today
evening, sir.
Evening, sir.
Very good evening.
today we have solved the session for week 4. Have you all covered the content of week 4 or yet to do?
Yes, sir, covered.
Yes, sir.
Mostly covered only for
Covered.
Okay, so first of all, uh, you all should go to joinpd.com. Okay, open a new tab or new browser, just open joinpd.com and enter the code shown on the right top of your screen, which is GLCRQQ. And also keep a pen and paper with you so that you can solve the questions which will be shown on the screen. And for each question, you will be provided 5 to 10 minutes to answer. If you are using your laptop and desktop, your view would be as shown in the left side of the screen.
LCRQQ.
And if you are using your mobile, then your view would be as shown in the right side of the screen.
LCRQQ.
Sir, what is the code, sir?
GLCRQQ. Yeah, if you're using your mobile, you have to click on the answer question shown on the right bottom of your screen, and then you can type your input for that question. Any other doubt in the week 4 we will cover after these slides. Okay, so let's begin with the concept first. So the first thing which we covered in the week 4 is to find the association between two categorical variables. And for this, you must be aware of row relative and column relative frequencies. So the row relative frequency is nothing but each entry of the row divided by the total of that row. So that's how you can obtain the row relative frequencies. And similarly, for the column relative frequency, like each entry you will divide it by the sum of that respective column, you will be obtaining the column relative frequencies. So after computing the row relative frequencies or column relative frequencies, so you need not to find the both. So only one will be the enough. So suppose you have computed the row relative frequencies and you notice that it is same for all the rows in our contingency table, then we will say that there is no association between the two categorical variables. But if the row relative frequencies are different for rows, like suppose there are 3 rows and row relative frequencies are different for first and third row, in that case you will say that there is an association between these two categorical variables. And one thing which you will notice is if row relative frequencies are similar, then column relative frequencies will also be similar and vice versa.
Sir, here I don't understand the meaning of same because in that video as well, ma'am portrayed different values, but they had a difference of 1 or 2. So is that covered under that same category?
Font is not necessarily be the exactly same, it would be more or less the similar, more or less same, approximately you can say. One is, let's say 0.46, then another would be 0.47, 0.48, then they will be considered similar.
How much difference we can consider?
It depends on, it's very subjective way it's subjective. It can change from person to person how much you want to consider it similar. But during this course assignment questions, you will see a major difference or very minimal difference. There won't be any ambiguity where you can't decide whether it's similar or not.
Sir, there is a number for strength of association like correlation for two numerical variables.
Yeah.
Similarly, is there a number for the strength of association between two categorical variables? Is there any number like that?
No, there is no such number like that.
Okay.
Only
So
way
we
is
just have to if they are similar, then we have to say that there is no association, and if there are different, there is no definition of similar or different. How much similar or how much different? There is no such.
very subjective. It's up to you if you want to consider them to be similar or not. But
Okay.
during this course, it would be either more or less same or two different. There won't be any ambiguity case where you will confuse whether to consider it similar or not.
Sir, can you explain with the boy stack bar chart?
Yeah, we will cover all that. Let's
No.
just start with-
So last thing, sir, like if we find it out the row relative frequency and it is showing non-associated, so then
Yeah.
for column also it will be same. It will show non-associated only,
You
no?
have to compute the both. If you compute, both will give you the same result.
Okay. Thank you, sir.
So we have to see only one, either column or row, or both.
Only one would do. You can check
Okay.
with both, but only one would give you the answer.
Okay.
So let's move to our first question. So consider the following survey question, that if you own at least one credit card or not. So person wants to do a survey like who all owns a credit card or not. So he went to Washington State University and he surveyed 100 freshmen, 100 second year students, and 100 seniors, and noted down their responses in this table as shown below. Like 42 freshmen owns the credit card, 58 do not. Similarly, 81 seniors on it, 19 senior don't own it, and so on. He tabulated this data over here. So you have to find what proportion of total students are sophomore or the second year students, in other words, you can say.
Will be 0.95.
Done, sir.
Okay, so let's move to your solutions first. Okay, so we have asked the proportion, not the percentage. So I think many of you have also entered 33.33. Okay. So be careful while reading the question. So
it would be 0.33, right?
Yeah.
Okay.
But few of you have input 33, I can see. Okay. So in general, there are total students is 300 because we have surveyed 100 freshmen, 100 sophomores, and 100 seniors. So in total, you have 300, out of which 100 belongs to the second year. So the proportion of second year students is nothing but 100 upon 300, which is 0.33. Any doubt in this one? Anyone?
No, sir. I just want to ask one thing. This kind of question will come in the examination.
In examination, you can expect like the similar questions you have done. Like you have done a lot of questions, so the concept would be the same.
No, I'm just saying category versus category thing are.
But
this
I have
kind
doubts.
of.
It's in syllabus, so it can come. No.
I have one doubt.
Yeah.
Actually, is sophomore 55 plus 45 only.
Yeah.
Then why it has come to 100? Yes, 100. Okay.
It's also mentioned in the question. That
Okay. Thank you.
Yeah, I have a query, sir.
Yeah.
I have put the answer as 33%, but the answer that you are showing the proportion as 0.33. So should we not put the 33.33?
No. Proportion, the range of proportion is only 0 to 1. It cannot go
Okay.
beyond.
Okay.
If it starts in percentage, then you have to input 33.33.
Okay. Fine, sir. Got it. Thanks.
Okay, so in the second question, you have to find the proportion of total students who do not own a credit card. Okay.
Sir, can I ask something?
Yeah, sure.
If there is saying that for up to 0.2 decimal, right? So if we calculate something and the answer is like that 0.759, so we should do it 0.76 or 0.75.
It would be 0.76 because if you have to answer till 2 decimal places, right? Then you must compute till 3 decimal place, and then you check the third decimal. If it's 5 or greater than 5, then you increase the second decimal by 1. Otherwise, it remains the same.
Okay, thank you.
Yeah. Do you guys have any other session from 8 to 10 today?
Yes,
Mathematics
sir. Maths, sir.
Yes, sir. We have session
Mathematics,
from
sir.
7 to 9. 7 to 9, there is one session, I think.
7 to 9, it won't be.
8 to 10. No, 8.
8
Sir,
to
8
10.
to 10 mathematics and I think
Oh,
there is one
sorry.
CT also.
30, I
additional.
think. Yeah, from 8:30, I thought like having
Yes, from 8 o'clock. 8 to 10.
session.
Okay, let's we move to the solution for this one. So we know that total students are 300, and we want to know the proportion of students who do not own a credit card. So the number of students who do not own a credit card is nothing but the sum of the second row, which is 58 plus 45 plus 19.
90.
These many students do not own a credit card. So you know the number of students who are like total number of students, and you know the students who do not own a credit card. So their proportion would be nothing but 122 over 300, which is 0.41. Right? Any doubt till now? Anyone?
Sir,
No, sir.
Yeah.
its answer is actually for 0.4066. So if we write in 3 decimal 0.406, it will be right or wrong?
It's better if you write, but it's actually asked. But generally we have ranges, but it's still better if you make, because suppose you are getting answer 0.4066, right?
Yes.
You have to round it off till 2 decimal places. So for that you need to compute till 3 decimal place. Okay. Then consider the third decimal place. If it's 5 or greater than 5, then you add 1 to the second decimal place.
Yeah.
Thank you.
Which is 0.41. Okay. Had it been let's say less than 5, let's say 0.401, then you will keep it same, 0.40 only. Okay.
So that's why the answer became 0.41.
Yeah.
Sir, when
Thank
I
you, sir.
calculated and calculated, it said 0.406666.
Yeah.
So, yeah. So should we round it off to 0.41? Because mine.
Yeah.
Okay.
Because the question you have to answer correct 2 decimal places only. So you must round it off till 2.
So it says of 0.406667. So the round off would be 0.41, sir.
Yeah, it says 0.406667, right? So first consider only the 3 decimals, because we need to round it off till 2 decimal, right? So consider only the 3. After that, take a look at the third one. If third one is greater than or equal to 5, you add 1 to the second place. So that's 0.41.
Sir, if the second place is also on the margin, like on 4, and when we are rounding off, we carry forward 1, and this second position becomes 5 or greater, then should we change into the first decimal also, sir?
If you add, it would be 0.50, right?
Okay. Thank you, sir.
Okay, moving forward to next question. So next is again the same data set. You have to find the proportion of students who owns a credit card are freshmen. So of all the students who owns a credit card, you need to tell the proportion of freshmen or first year students. Okay. Okay, so let's move to the solutions. Okay. I think one is just randomly plugging in some values. Okay, so number of students who owns a credit card is nothing but the sum of first row, which is 42 plus 55 plus
178.
1. So it comes out to be
178.
178. And out of this 178, only 42 are freshmen. So the proportion of freshmen among all the students who owns the credit card is nothing but 42 over 178, which comes out to be 0.24.
Sir, here I have a doubt for rounding off. So I got 0.235.
Yeah.
So how do we round it off? It is less than 5, no, sir.
No, it's 5 or greater than equal to 5, then you add 1 to it. So it's 0.35 is greater than or equal to 5, right?
Okay, greater than equal to 5. So every time we check for the three digits only.
If you have to answer till 2 decimal places, you must find till 3. If you have to compute till 3, you must find till 4.
Okay, sir.
Sir, same doubt. I have same doubt, sir.
Yeah.
For example, sometimes what happened in question in a graded assignment or something like, so 1.25, you have, when they ask for take a higher number, then 1.25. So shall I take 1 or I mean, shall I have to take 2, sir? In that case, sir? If the number is 1.25, for example, and they are asking us to take a higher number than that.
Yeah, then it would be 2. Next highest integer, right?
Next highest integer, yeah.
Yeah, 2. It would be 2 then.
So what
yeah.
But then without rounding off, I've given my third graded assignment or something, but then it accepted my answer, sir. Like I got my answer correct, even if I didn't round it off. So what do you suggest, sir?
Yeah, what happens is usually in graded assignment and quizzes. So suppose you have to find the answer. Suppose the exact answer is 0.24 rounded off to 2 decimal place, right? So
Yes,
it is
sir.
possible that some of you, due to some tedious calculation, might have made some minor mistakes. So we don't expect the exact answer always. That's why we have some range. So if you input your answer, any number within this range, it would be considered as correct.
Okay.
So that's how it actually works.
So even like in exam also, is it the same scheme, sir?
Yeah, it's the same. Whenever we, like it won't be in all the question, but whenever we feel that you could have, that the calculation is a bit tedious and there are possibility of minor mistakes, we always put some range. So if you answer in this range, you will get the answer.
Okay, sir.
But it's still the best practice to, round
Yeah,
off.
round it off. Yes.
Okay, moving forward, it's again the same data set. You have to find if the row relative frequency is similar for all rows or not.
Can I ask a doubt?
Yeah, sure.
Sir, what will happen to the value of covariance or correlation if we add a constant or multiply a constant?
We add a constant or multiply. Okay. So what should be the effect according to you? Obviously,
I think it will not change.
not change. Okay, why will it not change? Have you tried like plugging in formulas and solving it?
Yes, sir.
Yeah, it won't affect. Okay, we will see. We will come to those covariance and correlation, then we will do it.
Okay, sir. Thank you.
So one small query.
Yeah.
If while computing standard deviation or variance, if each number is multiplied or divided by some constant, then will that number be multiplied to variance or standard deviation?
Okay, we will cover it all. When we come to the concept, we will cover it. Okay, so 57 have said, okay, not same, 10 has said yes, and 2 still don't know what's relative frequencies. Okay, so for first row, if I consider, so the sum of first row is 178, which you have also computed in the previous question. So the relative frequency for the first element, which is 42, it's nothing but 42 over 178, which comes out to be 0.24.
24.20.
Similarly, for second, it would be 55 over 178.
30, sir, 30.
131.
Even, and
Yes.
for the last one, it's 0.4.
Yes.
Similarly, you
Sir,
can compare on the second row and the totals.
Sir, 0.2 here, 0.4. So they are not similar, right?
Yeah, it's not similar. So, so
Can I
yeah,
ask a question?
yeah, sure.
Sir, if we compute column relative frequency, it's pretty easier in this case because total is 100. If column relative frequency are not matching, so we can conclude row relative is also not matching.
Yeah, you can do it. That's the next question.
Okay, sir.
Sir,
Yeah.
Sir, what is total, sir? 0.3.
Total is the sum of first column is the total, right? 42 plus 58.
Divided by 100, sir.
Sir, when can we say the relative frequency?
If you know about the total, okay, let's see. So I think it's something yes over here. No, it's freshmen, sophomores, and seniors, right? So total is this. So your one row is containing 3 values for yes, second containing 3 values for no, and then third row is the total. It would be 100 here, 100 here, 100. So the relative frequency for it would be 100 over 300, which is nothing but the sum of this row, right? So this is 100 by 300. So it's all 0.33. So yeah, if you notice the vector, I think the first one was 0.24. Let's check it. It's 0.31 and 0.46 then. 0.31, 0.46. So these are the values you obtained for first row, right?
Yes, sir.
And for second row, you have obtained 0.48, 0.37, and 0.16. So to find if they are similar or not, you make a comparison between these two respective values. So 0.24 and 0.48, significant difference. They are not similar in any way. So you can say that these two are not similar in any sense, right?
Yes, sir.
So the answer will be no, sir, right?
Yeah.
Oh.
So one question, sir. In the previous the solution that you gave, for if we are talking about the sophomores, then are they related, sir? Are they similar?
sophomores, it's very subjective. Some would say they are similar, some would say they are not. But
Okay.
overall rows, they are not.
Okay, sir.
Yeah, you
So
want
what is the margin we should consider, sir, in our case for the qualifier?
not any exact margin, but yeah, you won't see such ambiguous case like
Okay.
0.3.
Okay. Thank you.
You
Thank you.
will see this major difference or very close. That's it.
Sir, we don't check it right to the right side, sir, like 0.24 and 0.31. That comparison would be good for column relative
Yeah, that we do
frequencies.
for column relative. Yeah.
Okay.
So,
Find it. Yeah.
so like total, total is 0.33 proportion. So
Yeah.
for suppose fishermen, we got like 42 for yes and 42, almost 42 for no also. Then also it will be similar or it will be different, sir.
Relative frequency would be different, right? Because the first would be 42 over 178, and for no, it would be 42 over 122.
No, sir, proportion are same, but the total proportion is 0.33. Like, sir, for
Yeah,
yes, the proportion
and
is
it's 84 over 300, right?
yes, sir. So I'm assuming for if case, like if it is like that, then it will be similar or not, sir?
Okay. Let me just write it down. Okay, so what case you are referring to? Just tell.
So here I am referring that we have taken out the proportions. So
Yeah.
for freshman, we got the proportion of around 0.42. So hypothetically.
Okay, for the first one here. Okay.
Yes, so 0.42, and for no we got 0.41 or something like similar to 42.
Okay.
And sir, for total, so total it is 0.30. So in this case, it is similar or not, sir?
Different.
So means we compare it with total now,
Yeah,
both
for
the values.
total would also have to compare.
Okay, yes, sir. Yes, sir.
How can
Clear,
we find total, sir?
Total is it's nothing but the sum of the two, right? So here, if you look at total for total freshman is 100. So your another row of total you can add, which would be nothing but the sum of each column, right? So for if you add a new row total, then first element would be 42 plus 58, second would be 55 plus 45, and the last would be 81 plus 19, right?
So, may I ask a question, sir?
Yeah.
So I have the same doubt which another girl asked. I still am confused because row relative frequency, we are finding the proportion to the row total.
Yeah.
And column relative frequency, we are finding the proportion to the column total. But
Yeah.
when we are comparing for row relative frequency, we are comparing it column wise
Yeah, we
down.
compare column-wise, yeah.
Okay. And when we are talking about column relative frequency, the comparison of similarity is row wise.
Yeah.
Okay. Okay. Thank you, sir.
So yeah, this question I think you don't even have to compute. If you have computed row relative frequencies, you already know its answer. You don't have to do a lot of work in this. But yeah, see, yeah, 53 I've answered no. Okay, great. So you can also see, like, verify over here that if row relative frequencies weren't same, then column relative will also not the same, right? Or similar. Any doubt till now? Anyone?
No, sir.
Sir, I have a doubt.
Yeah, sure.
So is we are going to compare with the total also? So with
Yeah. You have computed the column relative frequencies, right?
Okay. Okay.
Consider these four elements you have. Okay, let's say. Are you guys aware of vectors by now in mathematics?
Yes.
Okay, let's get a bit. So another would be that this will be in another column, right? Total.
Yes.
In general, you have four columns. You will get some value over here. Let's just note down the values. It's 0.42, 0.58, 0.58. The last is 0.59 and 0.41. Okay. So in general, see, you have 4 elements. One is 0.42, one vector you can say. Let's just 0.42, 0.58, right? This one. Second is this one. Third you have is this one. The last one you have is this one, right? So we take a comparison of these two elements, these two, and then these two. So you see that these two are not similar, you don't need to check any further. Here also you will say that not same.
Okay. It's column related frequency, right?
Yeah. Column related frequencies. Okay.
Thank you, sir.
Anyone, anything else?
Sir, I have a doubt.
Yeah.
Sir, even if the frequencies are same for one column, can we call it as similar?
No, it should be same for all. Even if it's different for only one column, then you will also say it's not similar.
Okay, sir. Thank you.
Sir, how total is calculated in this case?
Okay, so total is, so you will have a row total, right? 42 plus 55 plus 81.
178.
And the second row total is 122, right?
Yes, sir.
So your another column would be this one. You add all these total values, 122. So if you find the column relative frequency for this column, it would be 178 over 300 and 122 over 300, right? Is it clear?
Okay, yes, sir.
Column relative frequency, we have to add up rows, and for row total, we have to add up columns.
Yeah. Okay, moving forward, this is the, I think the main
If the
question.
elements need to be different, or only one or two elements need to be different, then only we can say that it's both the frequencies are different.
Even if one is different, you say it's different. Even
There's
if
a single difference.
yeah, even if single element is different, you will say they are different.
Okay, sir.
Okay, so that's the major question for which we have done all the calculations till now. Is there an association between the year of study and owning a credit card?
Done, sir. Done.
Okay, so 15 have responded no, 45 have responded yes. Okay. Okay, yeah, since the row relative frequencies are, or column relative frequencies are not similar for all rows or columns, we say that two variables are associated. Okay, just a general question. Why we say that there is an association when the row relative and column relative frequencies are different? Anyone?
Sir, can you please explain that question once?
Yeah, anyone wants to answer like why it's
Yes, sir.
Because it is
Actually,
representing the variation.
Okay.
But
Sir,
it's
we are
same, there is
relating
no
to
impact,
different
right?
tables.
Sir, as one variable is increasing, the other variable may or may not increase. So they are not related to each other.
So since question is being asked on owning the credit card in relation with the seniority, obviously it is just because of the number there, and then obviously it is varying. If it is all same, then that correlation would have not been there. It would have not made any impact depending on the year because they're all same.
Yeah. Okay. So those who didn't understand, okay, let's assume it's same for all, right? Let's assume just a case.
Okay.
Right. Just a random values I'm plugging in. Okay, so let's make it 0.4. Just random values I'm plugging. Okay. So if you see, if a person is a freshman, right? The proportion of them owning a credit card is 0.24, and it's same for not owning, right?
Yes. That's mean there are no relation. There are
Yeah, it doesn't matter.
association.
Yeah. Similarly for sophomores, so we are not getting any change with them being in different years and owning a credit card.
Yeah. And here is the answer is 0.4616. So is it yes or no?
Okay, let's consider these value. I think it would be better. Okay, so see, so if a person is a freshman, then the chance of them owning a credit card is 0.42, right?
Yes.
But as it becomes a second year student, the chances increases to 0.55, and for senior it's the most, it's 0.81.
Yes.
You can see a clear difference that as the year of study increases, the proportion of them owning a credit card also increasing.
Increases.
So there is an association, right? Whenever if it had been the same, it doesn't matter in which year are you, the chances are same of owning a credit card. So if the frequencies are same, then we say that there is no association, while relative frequencies, when it comes out to be different, we say that there is an association.
We like compare like this. The freshman is less, but sophomore is more than that, and senior is more than that.
Yeah,
so
it keeps
it's increasing.
Yeah, as your year of study increases, the chances of owning is also increasing, right?
Yes.
Sir, we can
Got
also
it.
put this data on XY coordinate, no, sir?
Yeah, you can, but it won't be like generally we don't plot it. It won't give you any meaningful insights over there.
Sir, can we infer from this stack bar chart the same data?
Stacked bar chart, yeah, you can use to do that. So you can do that. So in stacked bar chart, if you plot, so I'm taking 100% stacked bar chart. Okay. So let's consider 3. It's for freshmen, it's for second year, and it's for seniors. Okay. So for freshmen, the chances are 0.42, right, for owning. While for not owning, it's 58%, right? As soon as it becomes second year, it becomes 0.55 and 0.45 for not owning. And for seniors, it's 0.81, right? So you can see a clear increase in.
Yes.
As the year of study increases, the percentage or proportion of them owning a credit card also increasing, right?
This
yes.
100% by stack bar chart and only bar chart. Actually, what
chart means
it is that
it is completely 100%, of which 42% ons and 58 does not. 55% on, 45 does not. So that's 100% stacked bar chart. We usually say.
no y-axis what only percentage.
Here I'm plotting proportion. You can also plot percentage. It doesn't matter.
Oh. Okay, thank you.
Okay, so assume now you know that when we say that there is an association and when we don't, with the logic behind it, right?
Yes, sir.
Sir.
Yeah.
If
second year have higher owning rate and the final year have low owning rate and the first year also have low owning rate,
And then also there is an association, right? Because whenever someone is second year, the chances increases significantly, right? So if I have to market a credit card, I will target only the second year ones in that case. There is an association. I won't target all the three groups equally. I will give more attention to the second year students in that case, right?
Okay.
If you own a credit card company, you will spend most of your money marketing for seniors only, because that's where you see a high successful rate, right?
But then this is not depends on the association. This is association kind of.
Yeah, this is an association. If there is no association, you can equally spend equal amount on all the three groups, right?
Yes, then all these things will be 0.4 to 0.4 to 0.4.
But here you see that seniors are the one you can easily convert to your clients. So
we
they
have to
can
go for
spend more of
seniors.
the money.
So,
yeah.
So the graph you plotted, in that you plotted for column relative frequency. So we had 3 bars. So but if you would have plotted for row relative, then also we would have 3 bars or only 2 bars?
Only 2 bars.
Having three subsections.
Yeah.
Okay.
Two split it into 3.
Okay, sir.
So what you just said a minute ago, is it inferential statistics, sir?
Yeah, I have drawn the inference from it.
Okay, thank you, sir.
Sir, to draw a conclusion whether.
Hello, sir.
Hello.
Yeah.
So do we need to convert these values into percentage?
No need. It depends what's asking the question. If they're asking proportion, then answer in proportion. If percentage, answer in percentage. For your own convenience, you can keep it all proportion or all percentages. It will be the same. No difference.
Sir, but which method is easy, to keep them in this decimal form or to convert them in proportion, to know the association between these categorical variables?
In general, you only need to compare the values, right? So if you convert it into percentages, you will be comparing 42% and 55% instead of 0.42 and 0.55, which is the same comparison in general. So it's up to you. Whatever you find convenient, you can go ahead with.
Okay, sir.
Sir, I have a doubt.
Yeah.
If question will be said that give in percentage, then we make it percentage. In proportion, we will give that proportion thing, right? The point thing.
Yeah.
Oh.
Sir, in concluding the association, do we have to every time calculate the total, the row relative frequency, column relative frequency, the total as well?
Yeah, you
like
have
it's not. I mean,
to match with total.
No, like in the previous case, like the third row, column relative frequency was way apart, right? So I can conclude that there is no association. No, is it a mandate that all relative frequencies have to be?
At least one is different, you will conclude that there is an association, even if at least one is different.
Okay. So in this case, I don't have to calculate the total frequency.
Yeah, even if one is different, you need not to compare any other. Even if you find one different, just go ahead with the association. Okay.
And sir, for similar, what we have to check?
One doubt.
Similar, you have to check all.
So like every value will be same, or like all the row and
You have to check if all the row relative frequencies are similar for all rows.
Okay.
Sir, I have doubt.
Yeah.
Sir, I have a doubt.
Interfering how cannot ask.
Can you repeat?
Actually, my doubt is there some question giving only standard deviation. What does it mean? Population or sample?
Only stand in this course, I think it would be everywhere mentioned whether you have to compute sample or population.
No, one practice assignment, but there is only standard deviation. So what by default, what does it mean? Population or sample?
It won't be that case. It would be mentioned.
It always be mentioned.
Sir, I have a doubt. So now we have computed for totals the graph. So It says that as the year is increasing, the purchase and they have a credit card. So that means it is different from what I mean. They are associated, so like
There is
that.
an association between owning a credit card and year of study, right?
Yes, sir.
Because as your year of study increases, the chances of owning also increases.
Yes, sir. But row and column frequencies are not similar. So if they are similar, they were not associated.
Yeah, if they were similar, there would be no association because it doesn't matter in which year you are studying. There are same chances of you owning the credit card, right?
Okay, sir. Got it.
If it had been similar.
Sir, move it
So
forward.
if they're not similar, related, I mean, they're associated with each other.
Yeah.
So move it forward, sir.
Yeah. Okay. Let's move to the next question. So there are two factories, A and B, okay, which produces the squared shaped wooden sheets of varying length. Okay, so you have this data, the factory which have produced the wooden sheet, its measure of size and area of wooden sheet as well. So you have to find the population standard deviation of measure of sites.
Done, sir.
Yeah, I think
Done, sir.
quickly move ahead this question. Yeah.
Wait, sir.
Okay, let everyone do. We still have only 20 of 24 responses.
Sir?
Yeah.
So in the point biserial formula, the standard deviation, sir, that is a sample standard deviation or a population standard deviation?
Population standard deviation.
It could be both. We'll come to that also. It could be.
Sir, in this question, we have to calculate population standard deviation, right?
Yeah, population standard deviation of measure of site.
Okay, sir. Done, sir.
But sir, in correlation formula, I guess there is a population standard.
It depends. We will cover all this. Let's just focus on this question for now.
Sir.
Yeah.
Why can't we write this table as a contingency table, as there are only two variables, A and B, means the factor variable?
Okay, but like you want to write it as a contingency table, right? Is it so?
Yes, sir.
But we need two categorical variable for this. So like in the previous one, we had the freshmen, like we have category of the year of study and they're responding say yes and no. So we had that count, right? Freshmen and yes, how many combos of freshmen and yes are there, freshmen and no are there. Here you want to have combination. So there are no two categorical variables. Only in case of multiple categorical variables, you can make contingency table.
Okay, sir.
Okay, moving forward. Okay, must have answered it. Okay. Later. Okay, so I think you all know the formula for population standard deviation. It's nothing but the square root of population variance, and the formula for population variance is 1 over n, where n is the number of observations, times summation xi minus x bar whole square, where x bar is the mean and xi's are the observations. So first, I think you have computed the mean, which comes out to be 3. Then you subtracted mean from the each observation, squaring it, adding them up, and plugging the
Variance.
Any doubt in this till now, anyone?
No, sir.
No, sir.
Okay, let's move to the first. You have to find the sample standard deviation of measure of size. Okay, one thing which I want you to do in this question is to not to compute again by using the formula. Just try to convert the population standard deviation into the sample one. Can you do it without, like, don't compute again that summation xi minus x bar whole square? You know, suppose you know the value of population standard deviation, okay, which was 1.095. You know the number of observations, which are 5. Can you find sample standard deviation from this data?
Yes,
Only
sir.
these two things are known to you. Just try
Yes,
to do
sir.
it.
Yes, sir.
Sir, what was the old answer?
It's 1.095.
Sir, calculator provided.
Can you repeat?
Will calculator be allowed?
It would be the on-screen calculator as you have in the portal.
Okay.
Only basic operations would be there to perform in that calculator, not all.
Sir, in that calculator, can we use keyboard? The
No,
number keys.
no, it would be only from mouse. That's why the calculation would be very simple in the quiz exams. It would be more of a concept.
Sir, we would be we would be able to find the roots and all those from calculator.
Roots all I think you can find.
It is given in the calculator, right?
Okay. So to look into it, you can Google TCS calculator, okay, and you can get your hands on it.
Yeah, you can find.
This calculator, go through it, and you can get an idea of how to compute and what all operations you will be having.
Okay, sir.
Okay, so most of your ones are close to one. Okay. Okay, first let's derive the formula for this. Okay, suppose you know population standard deviation, right? Or let's start with the variance. Suppose you know population variance. Its formula is nothing but this, right? So from here you can find the value of summation xi minus x bar whole squared, which is nothing but number of observation times population variance, right? And if you have to compute the sample variance, So sample variance formula is nothing but,
It will be n minus 1, 1 by.
so I can substitute this values over here. So it would become 1 over n minus 1 n times population variance. So if you know the population variance or population standard deviation, you can compute sample one, right? Only two things so you need to know, which is the value of n or either population one or the sample one, right? So here in this case, you know that, okay, you need to find the sample standard deviation, which would be nothing but square root of all this. So it would be under root n over n minus 1 times population standard deviation. You know its value. It's 1.095. And you can plug in the value of n and compute. You will get the same answer. Okay. So yeah, you may face some question where you will given only these two things. You will given value of n, you will given population variance or standard deviation, and you will be asked to compute the sample standard deviation. You can expect such questions as well.
Sir, in second step, from where did we get population standard deviation?
It's the under root of population.
Okay,
variance.
under root. Okay.
Is it clear or any doubt in this till now? So this is the form. Okay, so moving forward, it's the sample standard deviation of area of wooden sheet. Okay. So you have to now compute the sample standard deviation for this one. Okay. So, do you guys need more time in this or done?
No, sir.
Yes, sir.
Let's
Done,
just
sir.
spend for a minute. A lot of you have not answered it. Okay. Okay, so yeah, tomorrow morning the mock tests will be released. We will be having 2 mock tests. Okay. And it will be open till 5 p.m. on Thursday. And after that, we will have a mock session from 6 p.m. onwards.
Both the tests will be open till Thursday.
Till Thursday 5 p.m. Yeah, it will open tomorrow morning.
None of them is a
Sir,
time test.
after 6 p.m. session, what are you going to do, sir?
After 6 p.m. session?
Yes, sir. 6 p.m. session. Mock session.
Yeah, on Thursday we will have like deadline to submit the mock would be till 5 p.m. and from 6 p.m. onwards we will discuss the solutions.
Okay.
So tomorrow is also a mock session.
No, tomorrow you will be having on-demand session.
So what will be the timing for mock test?
On mock test, it will be available from tomorrow morning till Thursday 5 p.m. So you can attempt anytime in between.
Not timed one.
Timer, you can set timer for yourself while doing.
So for tomorrow's on-demand session, do we have a calendar link, sir?
So it's all informed only through the Telegram group. Whose link was shared through announcement. One on Friday and one on Sunday. I think we have sent 2 announcements regarding that.
Sir, regarding the mock test,
Yeah.
the level of difficulty, the pattern would be similar to what is actually going to come on Sunday?
Our questions in mock, it would be just the previous terms qualifier questions. So
Okay.
the calculation part would definitely be simpler in the upcoming mock because in the previous qualifier we used to give some tedious calculation, but now it's very simple because we test more on the concepts. So the calculation
And
part,
sir, do we have a time limit for mock session?
for mocks you can attempt it anytime from starting from
Like,
tomorrow till
will
Thursday.
there be a 4 hours like time given?
No, you can set a timer for yourself if you want, but
Okay, time.
I want to say something. Sometimes I did some mistakes in calculation, like just this. It is for in your case 8.664, and I calculated 8.769. So is it considerable or it is out of range?
it would be out of range. Because if answer is 8.643,
Hmm.
range would be 8.638 to 8.648.
Okay.
Sir, I'm getting
I did some
8.63
mistake and
after
it's
that.
8.76.
So can I ask something?
Yeah.
Yes, sir. Is there a particular Telegram group for statistics for this qualifier batch?
Not a group, it's a Telegram channel. The link has been shared with you all through announcement only. There is only one channel and the link is shared through announcement. One was sent on Friday and on Sunday as well we have sent the reminder to join it.
And not in the dashboard.
As far as I can see, we have around 1650 students joining that channel already.
We are not getting any announcements.
Not getting
For
any.
release, sir.
Yeah.
Check your email now.
Sir, correlation we find the population or standard variation or not, sir? Correlation.
Population.
Yeah, we will come to that also.
Okay, sir.
Regarding Telegram channel, how will get notice?
You might have got an announcement, right?
No, sir. We haven't, sir.
We don't get any announcement.
It's there in the announcement, sir.
In the announcement, I think if you're not getting any announcement, you can.
The link is in mail also. The Telegram link is in the mail.
Which mail? Mail already changed.
But there is no
mail is
updation.
coming.
There is no update on mock test on the Telegram channel,
No
sir.
mock.
No mock test. It's only
For
on
mock
demand.
test, you have to check your calendar.
So far we had only one on-demand session, sir. The other
So
on-demand
for
session.
one session yesterday we had it for week
Yes,
one
sir.
and
Yes,
yeah.
sir. Tomorrow, are we going to receive an link tonight or something like that, sir?
Yeah, tonight you will receive for week.
Thank you, sir.
Sir, do we get answer of mock test just after submitting it like activity questions?
No, for now it would be like you can only submit it till Thursday 5 p.m. After that, you can see your score in that, and then solution.
Like graded assignments.
Yeah, after that it will be made available for practice.
Sir, when we will get admit
Subject
first?
wise or all together?
Can you
Subject
repeat?
wise, like, will all the subjects be combined in that mock session or
No,
only
only stats. Only stats one.
So when we will get admit first?
You can ask support team for such issues. I don't.
Please proceed, sir. We have another session.
Yeah. Okay, so moving forward, this is again in the formula for sample standard deviation and compute the same, right? Moving forward, we have two things: covariance and correlation. One thing to keep in mind, it only tells you about the linear association. So covariance, the problem with it is it has units, so you cannot compare the two covariances with different units. So that's why correlation comes into play. Correlation don't have any units. It's a unitless measure and it ranges from -1 to 1. So you can compare the strength of, suppose you have computed a correlation for one data set and for the other data set, you can tell which one has strong linear association and which one is less. Okay. So Pearson correlation coefficient. So one formula is this shown on the screen. Another two formulas we have is, okay, so correlation coefficient, either use population covariance of x and y and divided by population standard deviation of x times population standard deviation of y, or if you are using sample covariance, then you have to divide by sample standard deviation of x and sample standard deviation of y. From both you will get the same answer.
Sample variance,
Sir,
right?
If you
I have
open
a
this,
doubt.
yeah.
In practice assignment 4.2, 12th question, they didn't mention whether we should do sample correlation coefficient.
In
But
graded
still-
assignment also, sir.
It would be
But
same.
still, the answer they calculated was sample using
Correct.
sample correlation.
You can
not
compute
population.
whatever you want. It would be the same answer.
Same answer. That's
Yes,
Sir,
here
sir,
n minus
reason.
out.
Okay.
So it's again this formula. And
yeah, same form.
here also, if you do, it would be okay. So its population would be n only. Okay. 1 over n. So nn gets cancelled out, right?
Yes, sir.
Here n minus 1 would get cancelled out. So you will get the same answer whether you use the population 1 or the sample 1. Okay.
Sir, why we try to differentiate population sample by -1?
That you will study in stats too. It has a very basic behind it, inferential statistics, which you will cover in stats too. Okay. For now, just remember for sample it's n minus 1.
Sir, can I ask a question in previous question?
Yeah, sure.
Sir, in this question, the area is just the square of the side. So in that way, we can define any relation between standard deviation of both or not.
No, you won't be able to do.
Okay, sir.
Okay, so yeah, here you have to find the sample covariance between the two. So why we are finding sample covariance? Because now you have sample standard deviation of measure of side, you have sample standard deviation of area of wooden sheet. So once we have the sample covariance between the two, we can compute the correlation coefficient, right?
Can you show the answer of the previous one, sir? I just did some mistake on that answer.
Yeah, can move. So previous one, it's 8.64.
Thank you.
Just quickly wrap it up. Yeah, can you repeat? Okay, so do you guys need more time or done with it?
Yes, a few more seconds.
Sir, wait a minute.
Sir,
Yeah.
if we get one decimal place answer or in question we have asked for two decimal place, then we increment zero only.
Oh, you okay? Are you done with this or guys still doing the calculation stuff?
Done.
Done, sir.
Let's just wait 30 more seconds. And then okay, so most of you have answered. Okay, around 11. Okay, so you just have to compute the mean of x and mean of y. I think most of you have already computed it. And then you have to find the deviation of each observation from their respective means. Like we have computed xi minus x bar and yi minus y bar. Then you have to find the product of these two for each observation and then sum it up, right? And then plugging in the formula, you can compute the sample covariance. Any doubt till now? Anyone?
So for covariance, there should be always two variable.
Yeah. Covariance is just the association between the two variables. So it must have
Association between two numerical variables.
linear association. Yeah.
Can covariance be negative?
Yeah, it can be negative. It can be negative. Yeah. Okay, so yeah, moving forward. Now you know the value of sample covariance between
Sir,
two
I have one doubt. Actually, what is the difference, major difference between covariance and correlation?
covariance and correlation. Okay, so major difference between the two is, see, the motive of both were the same, but what happened earlier, we had only covariance to find the linear association. So the problem in it is, suppose I have one data set. Okay, in this data set, this variable is measured in kg and this variable is measured in meters. Okay, so the covariance will have unit kg meter. And for the second data set, suppose it's in gram and it's liters. So for second data set, I will have value of covariance in units gram and liter. So I cannot compare these two variables, because you cannot compare two values in different units, right? So what happens in correlation is there is no unit in its unitless measure. It don't have any unit. Because if you see, suppose consider this data set, right? So correlation formula is this. So let's just plug in the units. So xi minus x bar, it would be in kg, right? It would be in meter. This would be under root of kg squared, under root of meter squared. So it would be again kg meter. So it gets cancelled out, right? So it's unitless measure. So now if you have
Size of covariance, however difficult, it
Hello,
cannot.
let him complete first. Yeah. Size of covariance. Hello.
Hello.
Yeah. So who was
Actually,
asking? Just continue. Yeah.
because there is a units, we cannot predict the size of covariance.
You cannot compare the two. Like you have this data set 1, data set 2. You cannot compare the which one has the stronger association, right? Because they both are in different units.
Then what is the use of using covariance? What is the purpose then?
Covariance was used, it was used earlier. Then we introduced with the correlation, and to compute correlation, we use the covariance part only. We just standardize the covariance so it becomes unitless. That's all.
Okay.
Hello, sir.
Yeah.
So will you please show the earlier question's answer?
Earlier question, which one?
So that covariance, oh yeah, this one.
That's 10.5. Okay, so yeah, let's quickly do this one. You have to find the correlation between the two now. You know the sample covariance, you know the sample standard deviation of each. You just need to plug in the formula.
Sir, correlation lies between 0 and 1, sir.
-1 to 1.
What is the range of this value of covariance?
It's -infinity to infinity.
Sir, if it is exceeding one, so it is wrong, sir. The answer.
Yeah, it won't exceed that.
Sir, how do I measure the extent of relationship?
Can you repeat?
How can I measure this extent of relationship? It is coming as positive 10.5. So what does it imply?
Okay, so yeah, for comparison part, okay. I'm talking in terms of absolute values. Okay, if it's lies between 0 and 0.25, we say no, you can say absence of linear relationship. Okay, if it lies between 0.25 and 0.5, we say there is a weak linear association. If it lies between 0.5 and 0.75, we say it's moderate. And if it lies between 0.75 and 1, we say it's strong.
Sir, but the answer was 10.2 and it was above 1, no?
It's correlation.
ये तो correlation है.
Yeah, it's correlation.
Yes, actually the correlation here is going slightly above 1.
Yes,
it
sir.
was-
Means there is no
Yes,
absence of
sir, it
relation,
is,
linear relation.
Let me just. No, it won't go above 1. Just recheck your calculations, I think.
Sir, give me few seconds, please. I did a mistake.
Sir, can you please show the page where you wrote down the range of this correlation?
Yeah, sure. Yes.
Thank you.
We don't have to remember this range. We can have just 25 difference in every range.
Irrespective of the sign, you have taken modulus 4. So irrespective of sign, the relation holds good. Is it what that means?
Then if you remove the sign, you can consider from minus 0.25 to 0.25, it would be absence. Then minus 5. You can just.
By any chance, the numerator is 0?
Yeah, it could be. In that case, it is possible to have covariance as 0.
Because I'm getting 0.17.
Sir, can you give unlock scale once?
Yeah.
Thank you.
Please go back to the page, sir.
Which page?
Page where you have written moderate weak, strong, linear absence. Absolutely.
Thank you, sir.
Okay, so 38 of you have answered strong. Okay. Forward. So yeah, so sample covariance was 10.5 for X, or you can say that for measure of size, the sample standard deviation was 1.224. For area of wooden sheet, the sample standard deviation was 8.643. So just plugging in the formula, you get the value of 0.993. If it's greater than 0.75, we say that there is a strong correlation between the two, right? Any doubt till now? Anyone?
No.
Sir, can you please again explain that SX and SY?
Sx is the sample standard deviation of measure of sites, and Sy is sample standard deviation of area of wooden sheets.
Okay, got it.
Okay, so yeah, so now till now we have find the association between two categorical variables using contingency table, in which we did row relative and column relative frequencies. Next, we find the linear association between two numerical variables, where we use the Pearson correlation coefficient. Now, when we have to find the association between one categorical variable and one numerical variable, in such cases, we use point biserial correlation coefficient. And its formula is given by y0 bar minus y1 bar, where 0 and 1 are two different categories of categorical variable, and divided by the population standard deviation of the numerical variable times the respective proportion of each categories. Okay. So
what Thomas variable, sir?
Yeah, I will write it down just. Okay. So suppose you have this data set, let's say it's gender over here and marks. Okay. So let's say this is your data set. Okay. And let's consider marks. Okay. So here your gender is the categorical variable, right? Which has two categories. One is M and one is F. And your marks is the numerical variable. Okay. So you can consider any of these as 0th category and any of these as category first. So here I am considering M as the 0th category and F as the first. Okay. So in that case, if you look at the formula, okay, who is this?
We can consider female as 0 or male as 1.
Yeah. You can consider it either way. You can consider it as first and it as 0. It's up to you. So point biserial correlation coefficient is given by this.
Hello, sir.
Yeah.
Sir, then what if y0 mean minus y1 mean, we get a negative value?
Yeah, you can get it. It also ranges from -1 to 1.
It's a modulus, na sir, also.
No. We generally ask the absolute value. Because what happens is, if you take M as 0 and F as 1, suppose you got the answer of 0.57. But if someone else take M as first and F as 0, then he or she will get negative 0.57.
Yes, sir.
So that's why generally, whenever you see such question, we always ask for the absolute value.
Okay.
So in that case, you have to input this so that you have common answer to input, not different ones. Okay. So y0 bar is the mean of 0th category. Okay. So 0th category over here is, if I have considered M as 0, then y0 bar will be the mean of these two observations, right? Y1 bar is the mean of first category. So I have considered F as 1. So it would be the mean of these three observations, right? Third, sigma x is the population standard deviation of numeric variable.
But in the video lecture, it was given that it was sample standard deviation.
I'm coming to that also. Okay. Then P0 in that case would be number of observation which belongs to the 0th category. So here only 2 observation belong to 0th category and total are 5. So P0 would be 0.4. And P1 is the number of observation which belongs to the first category, which is nothing but 3/5. So either you use this thing, it's the easiest way to follow. In the video lecture, yeah, what has been told is
So point by serial covariance, what does it represent, sir?
it represents the association between the categorical and numerical value.
What inference? What out of this?
Let me complete first. So in that case, what happens is when you use the sample standard deviation, in such cases, the value of P0 and P1 changes. So your P0 will become number of observation which belongs to the 0th category divided by total number of observations minus 1, which is 2/4, while P1 remains the same. So if you are using sample standard deviation, you have to keep this in mind. If you're using population standard deviation, you can just simply.
Sir, both give the same value.
Yeah, both will give the same value. Yeah.
Even if the P0 value is different, the overall value would be same, sir.
If P0 value is different, here you will be using sample standard deviation, right?
Yes, sir, for sample and for population.
Yeah, so P0 will compensate the value of sample standard deviation and give you the same answer you get here.
Okay, anything can be used. I mean, can be used, sir.
Either of this can be used. If you want to use sample standard deviation, you need to keep in mind the value of P0.
So why are you not altering P1? Because there is root.
You can also alter P1. You can alter either one of it. So generally, just remember that you can alter any one. You can do either P0 or P1.
But there is under root both of them. So should both of them should not be altered?
No, only one will be altered.
Suppose I am getting some numerical value out of this. What inference we can predict about given data?
It's the same as we did for correlation coefficient. It's the same. The absence of association, weak association, and then similarly the.
Okay.
It's the same one. Moderate, and then the strong.
How can we say that the association is linear only?
Linear association we say for two numerical variables, because correlation coefficient tells you only about the linear association between two variables. It don't tell you about if there is any quadratic, cubic, or any other relation. It only tells you the linear one.
So by design, correlation will tell you only linear association.
Yeah, Pearson coefficient will tell you the linear association. Okay.
But let it be numerical or okay. I think I got my answer. Thank you.
So yeah, the last question is the measure of side weakly influenced by the factory? So here, if you see that factory is a categorical variable with two categories, A and B, and measure of side is a numerical variable. So you need to find if there is a weak association between the factory, which is categorical variable, and measure of side, which is numerical variable. So one categorical, one numerical, only way to find is the point by serial correlation coefficient. Okay. So that's how you know when to use point by serial correlation coefficient, when to use correlation, and when to use the contingency table.
Sir, for correlation coefficient, when do we use it?
When you have to find the linear association between two numerical variables.
Only two. Okay.
Two numerical variables.
Two numerical variables.
Okay, I think this is the last question. You do it.
Hello.
Yeah.
So yeah, we are which formula we are going to use?
What which formula should be used according to you?
So we have to measure of site weekly. That means correlation coefficient we have to calculate, right?
Okay, here you have to find the association between which two variables. Identify that reading the question. Which two variables you have to find the association?
Sir, I have one doubt.
Yeah.
Actually, last lecture you told there is what is the difference between this interval scale of measurement and ratio scale of measurement. I'm not able to understand.
Okay, we will cover that too after these slides and week 4. If we have time, we will cover it today.
Okay. Sir, what did you tell about RPB? What does it represent?
What thing?
RPB.
It's point by serial correlation coefficient. It's just a notation. Like for correlation coefficient, you just write it by R. And for point by serial correlation coefficient, you just write R and then PB as subscript. Okay.
Sir, hello. I am audible. Hello, sir.
Yes,
you
you
are
are audible.
Yeah, please say.
Sir, here we have to calculate point by serial.
Yeah, and why?
Sir, I have doubt, sir. Sir, in point by serial, one there is categorical variable and another is numerical variable. We use a point by serial.
Oh, yes.
But sir, here both are numerical variable.
Which both are okay? You have to between
Side
which.
and area both.
No, read the question first.
Sir, if there is absence, so should we pick no? So, like they just asked if it is weekly, yes or no.
Yeah,
So
for
if it is
weekly, it should be in between 0.25 and 0.5 only. If you read the question properly, it's saying it's measure of side and factor. These are the two words you have to focus on. Factor is a categorical variable with two categories, A and B, and measure of side is a numerical variable. So one categorical, one numerical. Only way to find is the point by serial correlation coefficient. Okay.
The value between 0.5 and 0.5 is gives absence of linear association.
Your voice.
Obviously, it should be a weekly association. It should be 0.5 to 0.7 mod R.
Sir, if the relation is below 0.4 or 0.5, then it is weak.
For week, it should be between 0.25 and less than 0.5. Right?
If it is between 0.25 and 0.5, then what is weak? No? That's the matter. Okay.
Weak.
Thank you.
So here the numerical, we're going to take the area of the wooden sheet or measure of the side for finding the standard deviation.
Read the question and tell what you have to find.
It produces the square-shaped wooden sheets with varying lengths of sides. So,
No, the main question is what you have to find. Is the measure of side weakly influenced by the factory? So do you guys need more time in this?
No, sir.
Done, sir.
A minute.
Hello, sir. Can you explain the regression question?
What?
Sir, when is it yes and when is it no? Just wanted to understand.
Okay, you have to tell if there is a weak influence or weak association between the two. So when the value is between 0.25 and 0.5, we say that there is a weak association, right?
If I'm getting minus 0.245, then
The absolute value should be in between 0.25 and 0.5.
if it is coming lesser than that, sir, 0.245 it is coming.
0.25. But should be the answer in that case according to you, 0.245. Okay. Let's just see. It would still less than 0.25, right?
Yeah.
It would be absence of linear association or the association between the two variables.
Value is coming minus 0.37. Wow.
Okay, let's just move to the solution. But let's see.
Sir, if it is greater than 0.5, then we can say strongly associated.
Greater than 0.75.
Okay. Can I see the answer, please, sir?
Okay, this is a ranges, right? If it's between 0 and, let me just do it. If is it in this range, greater than equal to 0 but less than 0.25, we say absence. Okay. If it is greater than or equal to 0.25 but less than 0.5, we say it is weak association. If it is greater than or equal to 0.5 but less than 0.75, in that case, we say that the association is moderate. And if it's greater than 0.75, we say it's strong. The max it can go is up to 1 only. So, okay.
So why it was done P0 as
Can you go to the solution page once? Just trying to check my numbers are right or not.
so why P0 was taken n minus 1, sir?
If you're using sample standard deviation, in that case, you have to take n minus 1 in the denominator.
Because P1 is taken as n only, not an n minus 1 there.
You can take either one of them as n minus 1 if you're using sample standard deviation.
Okay.
Okay, so let's just quickly move to the solution. So here I have used population standard deviation. So accordingly, I have computed P0 and P1. So these were the values I have obtained. So P0 was just 3/5 because I am taking zero category, like factory A as a 0th category. So I have 3 observation in it out of 5. So P0 is 3/5, which is 0.6. Factory B only has 2 observations. So proportion is 2/5, which is 0.4. I've computed the mean for these 0th category observation and first category observation. The population standard deviation you have already computed in the earlier question. It was 1.095. And then just plugging in the values, I got the value of negative 0.37. And you can see that the absolute value lies in between 0.25 and 0.5. So there is a weak association between the two variables. Okay, yeah. Any doubt in this?
Sir, if I calculated the sample state and deviation, then any problem?
No, it won't be. In that case, you have to change the value of either P0 or P1.
Sir, how we calculate y0 and y1?
Y0 and y1. Okay, let me just write this one. Okay, so we have this data set. Let's just clear it down. 2A, 2B, and then 1A. Okay. Right, this is the factory we have. And Then measure of side. We have observation 2, 3, 5, 2, 3. 2, 3, 5, 2, 3. So here I have taken factory A as the 0th category and factory B as the first category, right?
Yes, sir.
So y0 bar will be the mean of all observation which belongs to 0th category, which is this, and this. So mean of these three will be right.
Yes, sir.
Then we switch to y1 bar will be the mean of first category. So I have these two observation. So mean of these two will be 3.5, right?
Yes, sir.
Then if you're using population standard deviation of this, it was 1.095 as computed in the earlier questions. In that case, P0 will be the proportion of values belongs to the 0th category. So in total, you have 5 observation, right?
Yes, sir.
Out of which these 3 belongs to the category 0, which is 0.6. And these 2 belongs to the category 1. So their proportion will be 2 by 5, right?
Yes.
Then you can just simply plug in the formula.
So here you have not taken n-1 as a sample, right?
Because I'm using population standard deviation.
Okay.
If you're using sample standard deviation, in that case, you have to make it 4 instead of 5.
So can this be extended to more than 2 category variables?
There are other measures which is beyond the scope of this course for now.
Do we require to calculate the standard deviation for this or not?
Yeah, you need to compute, right? If you can use population standard deviation, then it would be pretty simple, I think, to remember.
In the qualifier examination, there will be same question as you have given a data and the number of questions you have asked. And is there going to be same in qualifier?
In qualifier, you will have questions from all the 4 weeks. The weightage would be 50% for week 1 and week 2, approximately, not exact, and a remaining 50% from week 3 and week 4.
What about term and exam?
What about?
Term and session, whether it will cover entire syllabus?
No, it's the same. It's quiz 1 and qualifier exams are same. No difference.
No, quiz 1 to 4, quiz 2, 5 to 9. What about term and exam?
Quiz 2 we will discuss when it's the time of quiz 2. Now I'm talking about only quiz 1 and qualifier.
Sir, how much will be the time of this allotted time for this exam, stats 1?
Okay, if you are going for qualifier, you will have 4 hours to complete all the 4. Stats 1, maths 1, and CT and English 1, right? You have 4 hours and you can switch in between anytime you want. You won't be having any specific time allotted to stats 1 only.
And if you're giving quiz 1, then it is 1 hour per subject, right?
Yeah, in quiz 1, it's 1 hour per subject. There also, if you have multiple subjects, you can switch in between.
So back to the question, sir. You have used standard deviation X as 1.10 something, right? 1.0 something.
1.095, right?
It is coming 1.2247, sir. Standard deviation in Google Sheet.
I use population standard deviation. Sample standard deviation is 1.2 something, which you said.
Sir, so answer is coming minus 0.75. So it is comes under 0.75 or it will evoke.
It's coming out to be this for me.
Yes, it's coming out this for sample variation of
Sir,
sample deviation.
Yeah.
Sir, will there be sir, will there be any computer in the exam, sir?
It would be a computer-based exam only, but you won't be allowed to use any Google Sheet or anything. It would be only just questions and you can see and input your answer.
In
Calculators will be allowed, right?
Calculator will be there on the screen only.
Sir, will Excel be allowed, sir?
No, Excel sheet won't be allowed.
Could
Sir,
you please confirm that
can I ask
that measure
something?
of association?
There is a question in EMQ. In EMQ, there is showing that from the given list of options, but there is no option.
Okay.
EMQ 1, question 3 in my here showing that from the given list of options, select the chart types which cannot be used for ordinal data. This is the line only given, then question 4, but there is no options to do this math.
Okay, let's me just check it.
EMQ for EMQ 1 and EMQ 2, the same thing is happening with me.
This is the list of options you have. These 13 options.
This is the option. Okay.
These are the options you have. So which question you are mentioning? Question number?
I'm question number 3. Then how we do this kind of thing? I'm not able to get it. If this is the option. Question 3, 4, I'm confused.
Okay, so from the given list of options, select the chart types which cannot be used.
For ordinal data. No, that's mean
For the chart type, option 4 is the chart.
median we can't use in ordinal data.
No, it's
In ordinal data, median we can use. No, Pareto chart is not a Pareto chart.
bar chart
Yeah.
you can, Pareto chart you can't, pie chart you can do, and there are no other chart type, right? So
Okay, then what will be the answer I write over there?
it's here. You can see the template file. So for question 3, then you put this colon and just write 5. That's all.
The option number.
Yeah, option number. You have to input it in the text file, and then you go there, select the zip over here, then choose file and input it. You can also go through this instruction video.
Okay.
And below instruction video, you will see this instructions for EMQ. If you click on it, you will see the slide. You can also
How
check
to answer EMQ. Okay.
You will also see it over here. So it's,
And sir, like question 2, there is a percentage given, but in bar chart there will be no percentage. So how could I answer that question?
question number 2, right?
Yes.
It is asking what proportion of students. So you have to convert percentage into proportion.
Okay. Then we have to answer.
Yeah, it would be any of the answer given in this list.
Okay. Huh. Okay.
So this
Got
is the
it.
common for all the questions.
Okay. Now I get it. I was confused. Okay. Get it. Thank you.
Sir,
Could you please
sir, in the last
confirm
question,
that?
you have used, hello?
Yeah.
Yes, sir. In the last question, you have used population standard deviation and not sample standard deviation. So do we always have to use population standard deviation for point biserial correlation coefficient?
No, it's up to you. If you are using population standard deviation,
Yes.
yes, your P0 will be the number of observation in the 0th category upon number of observation, right?
Okay.
Then will be number of observation in the first category divided by total number of observation. But if you're using sample standard deviation, in that case, your P0 will be number of observation in the 0th category divided by total number of observation minus 1.
Okay.
The number of observation in the first category divided by number of observation. Or you can also.
But the answer will be same, right?
Yeah, answer will be the same. Or you can consider this.
Could you confirm that on the measure of association, adding a constant or multiplying a constant?
What thing? Which question you are referring?
Sir, that I have asked about in covariance and correlation while adding a constant or multiplying a constant.
To the covariance. I'm doing it for population. You can do it for sample as well. Okay. So the formula is this, right? Okay. Now suppose I added, let's say I added a constant a to all observation of my x. Okay. So then mean will become x bar plus a also, right? If in each observation I have added a constant a, then mean will be x bar plus a, right? Do you know this, or shall we do this also? But do you know this mean thing, or you want me to do it?
Yes, sir. Yes, sir.
No. Just give me a minute. Okay, so if you plug in over here, see now what's happening is your xi is xi plus a, right? And x bar is now become x bar plus a. Yi remains the same for now, let's say. So if you open it, it would be xi plus a minus x bar minus a times yi minus y bar. So a gets cancelled out, right? So no effect of adding or subtracting a constant, right? It's the same. Is it clear?
Yes, sir.
Now suppose we do a multiplication. Now each observation of my x is multiplied by a constant a. So in that case, my mean will also become a times the mean, right?
Yes, sir.
Population covariance in that case would be 1 over n a times xi minus a times x bar. Yi remains the same. So a comes out, it would be 1 over n summation xi minus x bar. So this becomes a times the old covariance, right?
Yes, sir.
Yes, sir.
Sir, is this trend continues in standard deviation as well?
In standard deviation, it's also the same. Your addition subtraction is not affected, but multiply division is affected. So for covariance, no effect of addition and subtraction, but for multiplication and division, you have the effect, right? Similarly, you can try it for correlation as well. Right? This is the formula. So here also, if you add any constant, it will again get cancelled out. And in case of multiplication, here also, let's see, it would be axi minus ax bar, right? And here it would be again axi minus ax bar. Okay. Then yi minus y bar. Right. So from numerator, you will get a coming out as constant common. And here also you will have a square coming out because it's squared, right? Over here. Y minus y bar squared. So here if you notice that this a and this a gets cancelled out, so correlation remains the same. It has no effect of addition, subtraction, multiplication, or division. Okay.
Thank you, sir.
Okay. Anyone, any other doubt?
Regarding a ratio scale and interval scale.
Regarding ratio and interval. Okay, anyone wants to explain ratio and interval too?
That definition I know, but practical questions I'm not able to infer.
Okay, which question you are referring to? Any example?
Suppose this area of it, suppose area is given. How it can be ratio scale instead of interval scale?
Area is given. Okay, so what's the minimum value you can have for area?
Area will be minimum 0.
Minimum 0. Maximum you can have anything, right? Okay, so it cannot go beyond 0, right?
Yes.
It cannot go. It only will be till 0. Secondly, you can perform multiplication and division as well, right? Suppose I have this square of area 10 and this square of area 20. So we will say that area of square B is 2 times the area of square A. And it is something meaningful, right? Mathematically meaningful to say.
Yes.
So it cannot go beyond 0. It can, minimum value it can take is 0. You can perform multiplication and division, which indicates it has an absolute 0. It will come under the ratio.
It's all three conditions you have to check simultaneously.
Yeah.
These three conditions should fulfill to be a ratio scale.
Yeah.
one more doubt actually when you are explaining regarding this observation and variables. We are telling two conditions. One is it should be in column, and another condition it should be unique.
Yeah.
That unique meaning, I could suppose duplication of data is there. How it can be unique?
Duplication of data.
Suppose duplication of data is there in any column.
Okay, okay. So I think we have good examples in this. Okay, let's look at this, right? So each column heading is a variable, right? Because bike brand, its value keeps on changing. First it's Honda, then it's Yamaha, Suzuki, right? It keeps on changing. So bike brand is a variable, bike name is a variable, mileage is a variable, all these are variables, right? Who's asking this out? Hello.
Yes.
Are they not categories, sir?
All these are variables, right? Next, if you look at cases and observation is the one which uniquely identify each row. Suppose I say Royal Enfield, right? Then you don't know which row I am referring to. Either I am referring to this row or this row, right? You cannot tell which row I am referring to. But as soon as you say Yamaha MT09, you know that this is the row I am referring to. All the values are unique in this column. So each observation in this column you can refer to as case. Like Honda CBR, this would be a case. Yamaha MT09 would be a case. TVS Victor would be a case. All this would be a case, right? So each case must uniquely identify the row, because whenever you say any observation in this row, you will know which row you are referring to. There should not be any confusion whether you are referring to first row or last row.
Okay.
Is it clear?
Then what about this last four option TVS?
Last four, which one?
TVS row is there.
All yeah. When I say TVS, you don't know which row I'm referring to of all these rows, right? But as soon as you say TVS Victor, I know that I'm talking about third last row. So TVS Victor will be a case, not TVS, because TVS Victor uniquely identify a row. You know that which row you are referring to.
But TVS we cannot tell it is there.
Yeah, because if you are saying TVS, you are not clear which row you are referring, right?
Okay, understood.
Is it not the same? The observations, the case are same?
Yeah, it's the same.
Okay, thank you.
Anyone, anything else?
So means like I have a problem in finding, so in question how to find that they are asking for row or column. So especially in one activity question, can I ask, sir?
Yeah, sure.
So in activity question 4.3,
okay.
Question number 1, sir.
Okay.
So activity question 4.3, question number 1.
Okay, it's asking what is the relative frequency of bought items corresponding to website A. Okay, so here we are talking only about the website A, right? Within the website A, what is the relative frequency that someone has bought the item? So total number of customer who visited website A are 3,000, right? Out
Yes,
of
sir.
which 100 have purchased. So relative frequency will be 1,000 by 3,000, right? It's
Yes,
1 by
sir.
3. So that's how you need to interpret the question, like which column or row is it referring? Here it's referring to website A. Website A means column 1.
So here corresponding to website A means like we have to just see the column of website.
Yeah.
Total. Okay. Okay, sir. So actually I was confused, like they are asking about row, means row total. I did it for row total.
No, you have to see what's it's asking corresponding to website A only. So website A is the first column.
Yes, sir. Thank you, sir.
Okay, then yeah. Thank you, everyone. Good night.
Thank you, sir.
When are we meeting next, sir? Possibility before the unit 1?
The on-demand session hopefully tomorrow and a mock session on Thursday, evening 6 to 8.
On demand, any timing, sir? Because I don't see it in the calendar yet.
It would be informed only through a Telegram channel.
Okay. Wonderful. Thank you so much, sir. Good night.